I remember the times when I saw newspapers in Germany which showed now also Amsterdam is occupied. So I remember those times as a small boy. And I think the times are over where one nation can live and have benefit at the expense of others. I think that's history by now, or it's becoming history. And that's why I like global problems, because it brings people globally together to think about solutions. So also climate change maybe is the most important driver to transform peoples and nations into a humankind. This is not that I think that we should make the impossible possible, as we were challenged this morning. I'm not a royal, so maybe royals can do that. And actually, I'm speaking here to replace Prince Hassan from Jordan. He was originally invited for this talk, so maybe he also could have done it. My approach is to say, well, let's try to make the possible real. And I will try to give you some indication. Here you see the globe behind me, and the globe is having problems. And there is a new insight. A meteorite is on collision course with Earth and will hit around 2050. So this is a threat, and we can embrace this threat, as we learned this morning. And but what is this meteorite? Well, that's we. 10 billion. 10 billion people hitting Earth, and as we learned in the previous talk, an Earth which by that time might have a carrying capacity for about 3 billion people. So 3 men on 1 bicycle. That will not work very well. So we will have a problem. And one of the ways out is, well, it will change our security paradigm. We need a new security paradigm for the century, and that is the transition from national to global security, or just to humankind survival. And that can be positive. Okay, so having said that, I will tell you what I will talk to you in detail. As I already said, DESERTEC is, you will learn what it means. I'm the chairman of the supervisory board of the DESERTEC Foundation. And DESERTEC is, and I will talk today here on deserts, global powerhouse, as a global powerhouse for a world with 10 billion people. And DESERTEC, a breakthrough for energy, water, and climate security, with a question mark, because it's not there yet. Well, what does it mean? Why do we need energy and clean energy? To make the Earth fit for carrying 10 billion people. We see the decline of our biotope right now. And so energy is important for many things. Well, we need the problems that we have to face are, we have to limit population growth by maybe 10 billion people. We need more water. We can make water with desalination and reprocessing. We need more food. We can do it with irrigation, with fertilizers, and so on, and with transportation. We need climate stability. We need global justice. Without global and equal developmental opportunities for everybody. So otherwise we won't have peace. And we need a civilization and wealth, or some people call it prosperity. Now, how are they linked to energy? Well, that's here. So clean energy, clean and sufficient energy or power can give us water, because we can make more water from the sea. We can generate more food. By this means, if you have energy, we can get climate stability. If you have clean energy, we can have global justice if everybody gets enough energy. And we can have a civilization and wealth. Now, what about to limit population growth? Can this done? If you have more energy, maybe we can grow even more. But the fact is, that civilization and wealth is a limiting factor for population growth. All countries in wealth have almost no population growth anymore. So it is a consistent approach. To make more energy will not generate always more demand. Okay, now how fast do we have to change to clean energy? Here we are under time pressure. And just from the goal that the Earth's temperature should not grow by more than 2 centigrades, 2 degrees Celsius, that says this can be converted into a remaining amount of carbon dioxide that can be injected into the atmosphere. And that has been worked out by an institution. And so the result is, worldwide, we are permitted to inject 750 gigatons of carbon dioxide, whatever that is, this amount. That means, in terms of the present emission rate, these are 25 years. So in 25 years, the world has to stop or to give up the 2 centigrade goal. And you see in this table there that some countries have very little time. Europe has not much time, 12, United States only 6. India is 88, and Indonesia is 67. So this is clear that this cannot be achieved by single nations anymore, only in a global cooperation. So a global cooperation is needed to have this 2 degree centigrade limitation as a security measure for energy, and for this we need a 25-year strategy for global decarbonization. Okay. For this, I will give you a proposal. Before, how much energy do we need? Well, you can read these numbers. 5 megawatt hour per person and year is something which might be useful, which might be a realistic number. Then if we add electromobility to it, that's another megawatt hour per person and year. And then, if you take all of this together, for a world with 10 billion people, that is 60,000 terawatt hours. And so this can be, if half of it would be provided from deserts, then that would be this 30,000 terawatt hours. Germany has an annual consumption of 500 terawatt hours, just to give you a reference. Okay, what does this mean in practice? This means that in practice we have to set up 12 collectors, solar collectors of a capacity for 12,000 gigawatt. 12,000 gigawatt is quite a lot. That means 30 years you have to install each day 1 to 1.5 gigawatt. So this is not what we are used to yet. So this is the challenge ahead of us. Well, can deserts give us that much energy? Here in this graph you see this little red square. This little red square is exactly the area which receives per day or per year that amount of energy from the sun that humankind globally is using. So where's the energy problem? There is enough. Well, of course we have to get the energy away from the deserts and bring it to the people where they live, and this can be done by electricity. So or in other words, I should mention that 6 hours. It takes 6 hours on solar radiation on deserts to provide the energy of 1 year consumption. If we would generate half of these 30,000 terawatt hours as just a number to look at, then we would need that red square, which is shown there, which is 1% of the useful deserts. Not all deserts are useful. If there are sand dunes and so, they're not useful, they are exempt, they are taken out. And then it is possible. And starting from these deserts, power can be brought to where people are living by so-called high voltage DC, direct current, high voltage, supergrid. And so that's shown here. So these arrows represent a distance of about 3,000 kilometers. There's about 10% loss over that transmission length, 10% only. And within that distance from a desert, more than 90% of world population is living. So we are really talking here about a solution that could take care of the global problem, and not only of a few cases. Okay, Now, this is a technology which does it. How do we harvest this energy? So the sunlight is concentrated, like from mirrors, on a spot or on a long line, high concentration, it's very hot, and in the focal line here are pipes, and there is some fluid going in, and this fluid is heated up to 400 centigrades, and with this energy we can drive steam power plants, like normal steam power plants that we are having everywhere. Just the steam is generated by solar heat. And there is another important point. So there's also solar power at night with this technology. Because we first generate heat, and heat you can store, as you know from a thermos kind of, what is that? So here you see these two big canned heat bottles. And they are enough to run this power plant also at night. So we have day and night solar power, and with this we can deliver energy or power always when it is needed. And then thermal power plants have to be cooled. And in deserts we can do the cooling with air, or if you put the power plants near shorelines, then the cooling can be done by salt water. Look at the bottom part. So this is a diagram showing the collector fields, the storage, and on the left side the power plant, and then there is this cooling, and this cooling can be done as a desalination process. So you evaporate water, salt water, and you recondense it, and then you have fresh water. And this gives those numbers, amounts which are there. So in the figure, which I will show you later, I think 1.5 Niles will be produced in that way. So because that's about the energy which is missing, the water which is missing. Now this scheme, which would work worldwide, has been studied by the German Center for Aerospace for this region of Europe, North Africa and the Middle East. We call it UMINA. And the result is, well, we take everything together. We take the good wind sites, we take the biomass sites, we take geothermal power, we take all technologies for solar, photovoltaics, and the concentrating solar thermal power plants. And when we do that, we find that we can satisfy the expected demands. This is a development of the demand from 2000 to 2050. In the top figure, it is for the MENA region, and the lower figure, it is for the EU 25 at that time, and you see a big difference. The top one is growing rapidly. The European is about stagnating because of all the efficiency gains that we will have. And you see the fossil range down there, and the ones which is coming from the renewables, and this brownish area is from the desert power. So you see the deserts make more than about 50% contribution to the local, to the North African region, and now even more. Also the yellow band, which you see, is exported to Europe, and then the blue band on top is for the desalination. So 70 or 80% is coming from that source. In Europe, it is a little bit less, because we have other sources like wind and hydropower, much more. Okay, and this is now the result on the decarbonization that we can achieve with this transition mix. The curve that you see top up is as if the power plants are kept the same, but just being increased by numbers. And that would be the top curve of the emissions. And then what actually happens is shown the shaded regions as emissions, and this is down by 81% over the business as usual case. So here is a reduction, and this reduction conforms with that requirement that we should stay within that limits of for delta T equal less than 2 centigrades that I mentioned before. Well, so the desert, can DESERTEC protect us? The answer, in principle, yes. We have to do it. Well, a start has been made. Here is the DESERTEC Industrial Initiative that our foundation has initiated. So someone has to do it, so we approach big companies. They will be the winners of this transition. So this transition is replacing the consumption of fuel by building technology and deploying technology. And so here we have 12 big companies that forms now this DESERTEC Industrial Initiative during the summer, and it will extend over the year and the next year and include more. There are hundreds of companies have applied to become member. It was really like a tsunami, so the interest is really high. So this is very encouraging. And good. Okay. So that is that the implementation is now being planned and is being prepared. But not that they will do all the investments, but they will just describe a way that is possible. Well, how to implement? Well, there are 3 phases that one could distinguish, and I say this only here because I want to point out phase 1. First, we have to bring the cost of these technologies down by subsidized or policy-driven or subsidized deployment very fast. And in 6 years, we could achieve break-even with fossil fuels. And then it would be just economy-driven or market-driven. So we have to reach the market-driven phase, and then we have to crank up the production capacities and the deployment rates, and this is all can all be done within the frame what normally what industry can do. So there is nothing which is a real obstacle. The obstacle is at the beginning, that we need the financial support to get the market introduction. And this is what is always called this burden sharing and so on. Now, how much would it be? One can go into the details, and the result is, yes, about 40 billion euro would be sufficient to pay for that. And then, what is the cost of a bank? Is this more or less? So it's close. So we are each year is a huge conference with thousands of delegates just on money, which is about saving a bank. Well, but who should pay? I was promised 18 minutes, but it started with 15. So that's why I'm now a little bit not in line with the... I was informed that I have 18 minutes, but it started with 15. I just have to tell you. Well, let's take a look at the historic carbon dioxide emissions, because they are connected with 2 items, with climate change and with industrialization. And here is a photograph of the world at night, and you see where industrialization is going on very easily. Now here, the regions are presented with an area scaled to the historic carbon dioxide emissions, and you see the same regions, Canada, United States, Europe, and Japan, being the big ones, the enlarged ones. And when you look, there's a clear correlation. Now, when we look, what are these 3 early developed regions? They still take the benefits from the early emissions. And they have $35,000 per person and year as an income, while the rest of the world has $2,200. So that is our advantage that we are still taking. Okay, so the big emitters from yesterday are the big benefiters of today. Now, if you compare the per capita things, emissions is 24 times. We have it as the green regions, and we have an income 15 times as the green regions. So that is suggestive for a solution. If now these rich regions would make an alliance, a clever climate alliance, for these 10 billion people which are coming, then they should invest something from the surplus into those regions where deserts are nearby and can be used, and where there is strong growth, so that there are not coal power plants, and so new coal power plants are set up. You see them encircled at the lower figure. And so in fact, if since the income advantage is $31,000 billion per year in these top regions, and if I would take that money, some fraction of that money, to start the DESERTEC program in the desert-close regions, which have a strong growth, then it would be enough that they would take 0.2 per mil for a 10 years period of their excess income to finance this. And so that's what we have to organize, what we have to make possible, or what we have to make real. I think it should be possible, but we have to make it real. And so then my conclusion is the DESERTEC concept. So deserts can provide all the power needed for energy, water, and climate security, and equal developmental opportunities for all in a world with 10 billion people. And since all needed technologies for power generation, for transmission, for desalination are already available, and if we make clever alliances of technology belt and sun belt and organize them in the proper way, then we can get to this clean power on the global scale in time. And if initiation costs of about 40 billion euro are provided by the industrialized countries, that is about €5 per person a year over a 10 years period, and then global justice and can be achieved, that would be a matter of global justice to achieve this, and we need some strategic cleverness to do it. So at the end, the DESERTEC concept, what have we?
Time
we have all
again,
this, yes, this is the final.
now his gift confound.
To see that we can achieve this if you want to do it. So with Obama, we say, yes, we can. I would say, yes, we could, if we would. Thank you.